अस्सलाम वालेकुम।
वालेकुम सलाम।
जी क्या हाल है सब लोगों का?
अल्लाह का शुक्र है सर, आप सुनाए।
ठीक। जी ये बताइए कि हम क्या पढ़ रहे थे, कहाँ तक हमने पढ़ा था?
हमने सर दी ग्रेट वॉल तक पढ़ लिया।
The Great Wall. Okay. That means we move on to coordinates and catalogues. So let's look at the coordinate systems. हाँ 30 स्टूडेंट्स हैं। क्या स्ट्रेंथ है आपकी क्लास की?
50 है सर।
50, 32। Okay, so let's look at the coordinate systems we typically use to locate the terrestrial objects. First of the coordinate systems is the celestial system. Celestial system is based on the reference of Earth and Sun. Let's see how it works. You think of Earth as the center of a sphere. For example, here. And you imagine a big sphere about it. The sphere where the object under study is located on its surface. That means the distance, let me mark the distance. This is the distance, let's say R. The distance of the object from the Earth is like radius of this sphere. यानी जहां वो ऑब्जेक्ट जिस डिस्टेंस पे आपने लोकेट किया है वहीं पे आपने एक सरफेस इमेजिन करनी है, स्फेरिकल शेप। If it is spherical, then you need two more coordinates after the radius. You need theta and phi because it makes up the spherical coordinate system. So r is the distance that is already known from some other factors, not in this coordinate system. But in this system, we only measure the two angles to locate the object, theta and phi. Where theta is known as the right ascension. The angle is known as the right ascension with the symbol alpha. Whereas phi is known as the declination. The angle is called the declination with the symbol delta. So after the distance, this coordinate system is based on the two coordinates alpha and delta that are very similar to theta and phi of a generalized coordinate system. So let's see what are these two angles. For this, I would go to the sphere and you see in reference to Earth, if we observe this big sphere and we draw an equator, you know what an equator is? That equates a sphere into two hemispheres. So this is your celestial equator, and then this is your celestial plane. Now you can easily find where is this plane. After defining the sphere, the center, and celestial equator and celestial plane, let's talk about the motion of the sun. In the reference frame of sun, this is the Earth in motion. As we know, Earth is orbiting the sun. But in the reference frame of Earth, equivalently, the sun can be imagined in motion. When sun is in motion, in reference to Earth, it moves in a plane, the plane known as ecliptic. The plane of the motion of the sun in reference to Earth. This ecliptic is the plane where the perimeter of this plane is circular. It moves on the sphere, as you can see, and this perimeter, the circular perimeter, it intersects the celestial sphere at the celestial equator twice in a year, यानी एक साल की मोशन में ये 2 दफा इस स्फीयर के ऊपर मूव करता हुआ सेलेस्टियल इक्वेटर को इंटरसेक्ट करता है। एक दफा इस पोजीशन पे जिसका नाम गैमा है, जो कि डेट है 21 मार्च, और मार्च से अप्रैल, मई, जून, जुलाई, अगस्त, सितंबर, exactly after 6 months, it intersects the equator on the very opposite side of the sphere and opposite side of the earth at the date of 22nd September. So let's talk about this position gamma, that is intersection of the ecliptic and celestial equator. Through this position gamma, you have to pass a curve from the north pole of the sphere to the south pole that crosses this particular position gamma. Remember what the gamma is? The intersection of the equator and ecliptic. When this arc passes this position gamma, this arc works as the reference for one of our parameters, the right ascension, alpha. This arc is known as the celestial meridian. As you can see, the arc is known as the celestial meridian. So on the celestial meridian, alpha is 0, and then as the object is located on the celestial sphere, the alpha goes on increasing in the counterclockwise direction like this. In our case, when this object, that could be a star or a galaxy or a cluster or a supercluster that we have discovered at an arbitrary position Q, the alpha is measured counterclockwise like this. You can see this angle here. This is the value of alpha from the reference line celestial meridian. To measure alpha, that is just like your longitude. Just like your longitude, the alpha could be measured in degrees. For round the sphere, this is 360 degrees. That can also be measured in hours. That equals 24 hours. And that could be measured in minutes. That is like 24 into 60 minutes with the symbol of 1 prime, and if we multiply with another 60, we get it in seconds. These are various units of angle that we use for alpha. So one of the coordinates of this position is alpha, namely right ascension, just like longitude. Then where is the second parameter? Delta, the declination. For the declination, the reference is the celestial plane. This plane I am highlighting once more, as you can see. This works as the reference for the second parameter. As an object lies in the northern hemisphere, just like this point Q that we can see right now, then from the reference it is there, the delta is taken positive. For the representation that the object lies in the northern hemisphere. But as an object lies in the southern hemisphere, for example here, then this value is taken negative to show it is in the southern direction. So the angle measured, you can already see, this is the reference line, this is the reference in the plane, and here is this position. So this angle between the two lines is named as the declination, just like the latitude. Just like the latitude on the surface of sphere. So these are the two parameters that are used on a sphere of a radius. The radius is equal to the distance from the center. Very similarly, we work with another coordinate system, that is the galactic coordinate system. The galactic coordinate system is also made with the reference of Earth, but this time Earth and center of our galaxy. Where is the center of galaxy? In this case, it's there. Once again, you consider a sphere about the center with the radius. As you can see, the distance of the object at location Q, this is the radius, that is the distance. Then what are the other two parameters in this case? In this case, the two parameters are L and B. Once again, L and B are distances, but measured in terms of angles. So these are practically angles. Let's see how do we measure these angles. So very first thing is, the sphere is designed about the center of the galaxy with the radius equal to the distance of the object, and then there is the galactic plane. In the very start of this chapter, if you remember, we have talked about the galactic plane already, where most of the stars of our galaxy are orbiting the center. So you can see like this, they are orbiting the center. From this galactic plane, you pass the big arc, the big circle, that is the galactic equator. As you can see, the galactic equator is bifurcating the sphere into two, the northern and southern one. And now we have to see where is the meridian for the galactic coordinates. In this case, the meridian is passing through a point C, an arc joining the north and south along the sphere, where the point C is on the surface of the sphere, but it directs the location of Earth with the center of the galaxy. यानी इसको आपने सेंटर ऑफ गैलेक्सी कंसीडर किया. हमारा सोलर सिस्टम इस सेंटर को ऑर्बिट कर रहा है. हमने लास्ट टाइम भी पढ़ा था, एक पर्टिकुलर ऑर्बिट में हम इसको सेंटर को यूं सर्कुलेट कर रहे हैं, यूं. तो ये जो लाइन ऑफ साइट है of the Earth joining the center, this line is striking the circle, the sphere at the point C. The direction from center to the Earth. So as it intersects the sphere, the position is C, and you have to pass the meridian through this point C. And once again, the meridian works as the reference. That's why the value of this angle for the meridian is 0. And then along the sphere, you move counterclockwise from the top. As seen from the top, you move counterclockwise and keep on increasing the value of the L. That is just like your angle alpha in this case, also the longitude. So this point Q, where a star is located or a galaxy or a cluster is observed, the angle is measured from the meridian. That is the value of the L, as you can see here. What about the second parameter? That is very similar. You measure it from the reference of the galactic plane. If the object lies upwards, that means northwards, the value of B is positive. And if it is lying somewhere in the southern direction, then it is taken negative. So this is what we are doing with the two types of coordinate systems. I hope that you have somewhat learned what are the coordinate systems and how to locate the objects. Quickly, we look at a list of some catalogs. कैटलॉग आप शायद समझते हैं, अगर आप लाइब्रेरी विजिट करते हैं तो आपने देखा होगा कि लाइब्रेरीज में बुक्स को एक सीक्वेंस में अरेंज किया जाता है और उनको एक नंबर असाइन किया जाता है, तो वो बुक उस नंबर से जो है वो रिकॉग्नाइज की जाती है। जैसे आप कोई कोर्स पढ़ते हो तो आप कहते हो इस कोर्स का कोड है PHYS 408। तो ये बेसिकली आपने अपने सारे कोर्सेज को, जो शायद more than 30 courses होंगे, maybe about an average of 40 courses you study in your BS program, 40 plus maybe. Then you have categorized, you have made a catalog for the courses to list them. यानी आपने उसमें जब लेटर्स PHYS लिखे तो क्यों लिखे, कैसे लिखे, अगर आपने किसी के साथ जो है वो CHEM लिखा तो आपने क्यों लिखा, अगर MATH लिखा तो ये क्यों लिखा। और इस तरह से जब आपने नंबर दिया 408, 203, तो किस सीक्वेंस में आप नंबर दे रहे हैं, तो ये बेसिकली आप एक कैटलॉग प्रिपेयर कर रहे हैं कोर्सेज को अरेंज करने के लिए, किसी स्पेसिफिक और एक ब्यूटीफुल अरेंजमेंट देने के लिए। So as we discover the stars, radio sources, or galaxies or clusters in our universe, we list them as our discovery in a catalog. So without going into the very details, because that would be a big topic, then just like a librarian, how to prepare a catalog, but for general knowledge sake of information, you can look at some big catalogs. Messier must be name of somebody. यहाँ से लग यही रहा है कि ये किसी एस्ट्रोनॉमर का नाम होगा। यूरोप में ऐसे नेम्स जो है बहुत कॉमन है। This is a catalog dedicated for nebulae and galaxies. And when you discover a galaxy or nebulous, you give it a name. M, that means you have listed it in the catalog Messier, यानी मैं इसको इस लिस्ट के अंदर लिख रहा हूं, followed by the catalog number. इसका मतलब ये हुआ कि अगर मैं इससे पहले 101 इस तरह के सिमिलर गैलेक्सीज डिस्कवर कर चुका हूं और अब मैंने नेक्स्ट डिस्कवरी की है, तो शायद मैं अब उसको नंबर 102 दूं। और इसी चैप्टर में आपने इससे पहले कुछ इमेजेस देखे जिसमें आपने कुछ गैलेक्सीज या क्लस्टर्स को देखा तो वहां पे आपने देखा कि M84, M87 and so on. New general catalog, NGC, very similarly for galaxies, and catalog number, but in increasing order of RA. यानी जैसे आपका ऑब्जेक्ट डिस्कवर होगा, आप उसके राइट असेंशन की वैल्यू नोट करेंगे और इंक्रीजिंग ऑर्डर में लिस्ट करेंगे। यानी उस लिस्ट में आपके अल्फा की वैल्यूज ऑलरेडी होंगी, तो अगर वो ग्रेटर वैल्यू है वहां लिख देंगे, स्मॉलर वैल्यू है तो उस पर्टिकुलर पोजीशन के ऊपर आप उसको लिखो। So in other words, it's just a list of the objects and to name the objects. What about Abel? It is dedicated for clusters, A followed by the right ascension. Cambridge, third, fourth, fifth survey is used for radio sources, and also Ohio for radio sources, 3C, 4C, 5C, and Ohio O for another letter is given along with O for the declination and also for the right ascension. तो ये एक यूं समझ लें कि बहुत ही बेसिक सी लिस्ट है और बहुत ही बेसिक सी इंफॉर्मेशन है about the objects that we discover and we put them in a list. Let's talk about expansion of the universe. Expansion of the universe is just like a balloon. We already talked about maybe many times. That is blown as you have marked some dots on the surface. The distance between these dots is smaller initially, but as the balloon is blown with more air in it, it expands in volume, and the distance between them observed to be increasing. That is, in other words, a newer and newer space is created between the neighboring objects, could be galaxies or clusters. Very similarly, if you think of the surface of a bun that is baked in an oven. बहुत दफा आपने एक्सपीरियंस किया हुआ है, जैसे ब्रेड या बन या ऐसी चीजें जब आप ओवन में बेक करते हो, mostly we put some grains on the surface. maybe sesame seeds. देखे हुए हमने, बहुत ही कॉमन है। जैसे आप नान बेक करवाते हैं एक तंदूर में, ओवन में, बन बेक करते हैं आप, उसके ऊपर आप तिल जो है वो लगाते हैं उसके टॉप पर। These sesame seeds have shorter distance very initially as the bun starts growing. But as it grows, it expands, the objects move away from each other, and each object is moving away from every other object. And we say in a flat geometry, this is not possible. If I mark three positions, position A, B, and C, if an object moves away from B, it is moving towards A. If an object is moving away from C, it is moving towards B. How is that possible that an object moves away from every other object? That is, only if the objects move in directions that the space between the objects keeps on increasing. The intercelestial space in our universe keeps on increasing, and in total, if we want to draw the picture of a universe, we usually do it like this. In total, the universe seems to be expanding as the objects, all of them are moving away from each other. How do we know that the objects are moving away? Very basic law is the Doppler effect and the corresponding redshift. Let's talk about this redshift, where I have only 1 minute in this meeting, so I stop.